Good afternoon to all of you. Welcome to a new video from IBCS. In this video, we are going to discuss on the subject of database management. In my previous video, we have already discussed on the topics of normalization, what is functional dependency, and the different normal forms. The description will be given in the I button above. In this video, we are going to move on to the next unit, which is database transaction. So in this video, we'll discuss about the definition of database transaction, the application of database transaction, and the ACID properties of database transaction. ACID is an acronym that is used for atomicity, consistency, isolation, and durability. We'll discuss each of these properties in detail in this video. So let us start. So let us start with the video. We shall start with the introduction to database transactions, the definition, and then we'll move on to the application and the ACID property. So a database transaction is a unit of program execution that access and probably updates the various data items. In other words, it is a collection of operations that form a single logical unit of work. Now, for example, let us say one of us goes to an ATM to withdraw money. So, withdrawing money successfully is one transaction, but it involves a lot of operations such as inserting the ATM card, inputting the pin, selecting one of the menu, entering the amount that you want, and getting the money. So once you get the money, the entire transaction is complete. So that is considered as only one transaction, but in that one transaction there are different operations that are involved. So here we'll also take an example of a money transfer which is done from account A to B. So once the money is transferred from account A to B, that completes one transaction, but it has got several operations, 6 to be precise. So the first operation is that the database will read the amount of money in account A, then it will deduct $50 from account A, and then it will update. So let us say account A has got $100. So once it is updated, so $50 will remain. Then once the money is transferred to account B, the amount is read in account B, $50 is added, and then the account B is updated. So let us say the previous amount in account B was $500, and now after transfer it will become $550. So that completes one transaction. But there are different issues in carrying out these transactions. For example, if some kind of a failure occurs, so let us say the account is debited and in between there is a network failure, so that is one kind of a failure, or there are concurrent executions of multiple transactions that goes on. So these are few of the issues that happens in a database transaction. Moving on, now we'll see there are few properties that has to be adhered to when a database transaction is done, and those properties are very popularly known as the ACID property, ACID property. We'll discuss them one by one with the help of the example. So the first one is atomicity. So A stands for atomicity. So atomicity generally refers to the process of completion of the entire transaction. So in atomicity, only two things could happen. Either the entire transaction is carried out or nothing happens. There cannot be anything which happens in between. So let us say in this slide we have already completed the first three operations, and when we are carrying out the operations from 4 to 6, a network failure takes place. So what will happen? The money is deducted from the account, but it is not credited to the other account. So this cannot happen. So there is nothing called as a partial execution. Everything has to be incomplete. So it has to be completeness or fullness. So that is why it is called as atomicity. So that means either a transaction is completed totally or nothing will happen. Next is talking about durability. This is the last one. So durability, what happens? For example, a transaction is completed and the money gets transferred from account A to B. Once the transaction is complete, the database has to make sure that it stays that way. So for example, let us say once the transaction is complete and a catastrophe is hit, for example fire, earthquake, and whenever the recovery takes place, all the money should be in the account as it was before to the catastrophe. Moving on to the next slide, it is talking about consistency. So consistency means, for example, let us say account A has $100 and account B has got $500 before the transaction was executed. So if we sum up A plus B, the total would be 600. So that is the first step. Now what will happen once the transaction is complete? So that means once $50 transferred from account A to account B, still if you do a A plus B, it should be 600. So that is what it is. So after also the transaction is complete, account A has got $50, whereas account B has got $550. If we add up A plus B, still it is 600. That means both the account or the database is in a consistent state. So a transaction should make sure that the database is always in a consistent state. So that is consistency. And the last one is your isolation. So isolation means all the transaction has to be conducted in isolation. So if one transaction is executing, no other transaction can interfere with the data item of that particular transaction. So here in this case, let us say transaction T1 is working with data item A and B, so it has to be left alone till the entire transaction is completed. And then T2, T3 can take up the data item and they can work on it. So these are the four properties, which is atomicity, consistency, isolation and durability, that must be adhered to while doing the database transaction. In the next slide, I have given few of the example and application of the ACID property. You can go through that. I have already explained each of these points. So in this video, we'll end this one. Any doubt that you have, you can put it in the comment section below, and I'll see you in the next video. Thank you so much.